So I'll navigate through the through Blackboard first. As for module information, there is you can't see all these, but I can. So there is a module handbook. So there is a description of the module fully and a tentative schedule. So you can have a read through it at your leisure. So it's just for the record. And then I'll go to learning materials. So in learning materials we have, you can't see all these. So I have weekly sessions, tutorials, assignment, help, level 3 content and exam help. But all these are not open as yet. So weekly sessions are open. I'll open tutorials now when we go to the tutorial class. Assignment, it's not open. When I issue the assignment, I'll open that. And level 3 content, this is for you to, if you have just come to the class, you can go through the level 3. You don't have to, you've already done CFD now. So for the ones who have come for MSc or who have come just from another session, who didn't do design of fluid system, so you can use level 3 content to revise yourselves. Okay. So it's just for that. So for example, in level 3 I have put all the slides and tutorials as well. So you don't actually need the slides, you need the tutorials. So you have all the 5 tutorials. So it gives an introduction. You can do a fluent problem as well as a CFX problem. I don't think if you did level 3 with Kerry, you did CFX. So I have put fluent and CFX both. So if you just want to revise yourself, just go through the tutorials. They are very narrative in a sense that if you follow the narration, you will end up with the solution. So pretty straightforward.
Are we going to leave both CFX and CFD?
CFX and fluent, yeah. That's the idea. But you use only one for the assignment.
Mm-hmm.
But the idea is to.
We can choose which one.
Yeah. But you may end up, most probably you will end up using CFX rather than fluent, even though you have used fluent.
I've used CFX, so
I have
probably use CFX.
Okay, yes. So you may be more inclined to use CFX. And you will find that you will find that both the software are based on the same platform. More or less the same platform, and it will alleviate the fear of two pieces of software. That's the idea as well, because when you go to the industry, so someone comes and tell you, we have CFX, not fluent, so.
I'm going to use FEA somehow.
No, we are not using FEA in this module now, so it's only fluid. That's that. And when we go to lecture slides, lectures, so it's again pretty much well structured. So I have lecture 1 to lecture 5. Yeah, but we will be doing. Sorry, this is for old CFD. So if you go to the weekly sessions of the module, so for week 1 I haven't put a study plan for the week ahead, but for the next ones you will see a study plan as well. But it's just a description of what you are doing. So if you don't understand anything, just go back and have a look, but it's just for me it's just for the record. It's not the more important thing, but inside is the more important thing. And for week 1, have you browsed through it? Can you see?
No.
Has anybody logged into the module at all?
It's not open. I checked last night. It's not available.
Right, that's funny. So let me check that.
Might have been this morning. I just checked my phone last night.
Let me. Okay, good. So in the content, in the contents, you go to the curriculum resources. So in the curriculum resources, you have lectures, recorded lectures, and then you have the tutorial for the day and the files that are required for the tutorial as well. Yeah. So we are doing the structure is we are doing first hour lecture, and the next 2 hours you will be doing hands-on CFD.
So is that stuff that we've already done in design, like the tutorials every week? In the design tutorials.
So mixing elbow and things, did you do?
Is that so?
Mixing elbow, did you do the mixing elbow?
Yeah. But no, we did the non-Newtonian elbow. Nothing.
No. These are different tutorials.
Oh, okay.
Completely. Yeah. No, they're not those tutorials. No.
Is it like the other ones that are on that?
Yeah. So these tutorials are more advanced ones,
Okay.
and no, there is not much of an overlap. Yeah. You won't have an easy ride. No, sorry. No, but it will be interesting. These tutorials are pretty. All are self-learning tutorials, so we just follow the instructions, and the theory is also there. So it's pretty straightforward. Right. So we'll go to the first lecture. So today we will be looking at an introduction. So it's a 15 credit module, so 11 lectures, 11 tutorial times. Assignment is 75%, 25% is for the exam. It's a 2-hour exam.
How did you examine software?
It's not just an exam on software, it's an exam on CFD theory. You did one for computational fluid computational methods, yeah? In the third year?
No, we never had to do it. No, we kind of just coursework.
It was just coursework.
Oh, was it?
Yeah.
Right. Okay, this is different then.
Yeah.
Because when I did computational methods, I had one on my exam.
Yeah, we were meant to have one.
It's just because the code.
Ah, okay.
Right?
Yeah.
The classrooms and that one.
Don't worry, I'll prepare yourself for the exam as well. So. Yeah. So.
This is all.
Am I supposed to be able to see this? Am I supposed to be able to see this?
You have 4 hours to do it.
I can see which one and we combine these with these two.
No. You're supposed to see it at some point. But
Well, okay.
so, Blanked it out. Yeah, thanks for letting me know.
Oh, also,
Yes.
ANSYS isn't on apps anywhere.
What?
ANSYS is not on apps anywhere. Neither is SolidWorks, like those programs.
You can get student versions and download
Yeah,
Can you hear
them.
that?
Yeah, I've got one.
Okay.
Crap version.
SolidWorks is heavy though.
Pardon?
SolidWorks is heavy though.
Okay.
40 gigs for SolidWorks, if I remember correctly, because I have it. And ANSYS also can be downloaded. The student version is going to be a lot weaker than the version available in university. But it should be done. It should be good enough for the tutorials.
I used a version on about that stuff. So
Is it the new
it's not,
version?
it's not there.
Yeah. Well, I was on the 2021 on the same one.
And it's compatible with the one in university.
Yeah, the other ones.
Yeah, I downloaded it from site here and installed in my office laptop and it works.
Because they changed it.
But you need a
Because before you could just do an apps anywhere.
you need to log into the system at least every 7 days or something.
Every 3 days.
Is it?
It's so annoying. Yeah. It's so annoying.
I'm just come here and do it.
Yeah, with student, on the student version, you can't have just load of those.
But you know the ones on campus, is that not super version
No, it's
No,
not.
It's
those
full.
are full.
It's a full version.
either?
The student version has a limit to the element count that you can use,
Okay. Yeah.
which for FEA is not bad, but for CFD, it just, you get over the limit really quickly. In the simplest of parts, you get over the limits.
Yeah. And the thing is, it's only a limit on the mesh. The software is the same, so it takes the same space in your computer.
If
32.
the mesh is bad, then the results are wrong and kind of off. And
You need 32 gig or something like that to install, don't you?
Yeah.
16 is the software space, but you need 32 gigs to install. Heavy on your computer. There are so as I said, you have lectures and instructions for exercises separately, as I showed you, and so you don't need your computer with ANSYS student version of it, but ANSYS you can use ANSYS at home or here, so it doesn't matter. Well, you are in this module. You are I'm here, David is here, but you are mostly on your own in a sense, because those are guided tutorials, so we will help, but you have to do it yourself. So this is a structure. This is the structure of the lectures. So we talk about the CFX and space claim, and then this is for the software learning, not the theory. Yes. Space claim and refresher on ANSYS. So then we talk about workbench, ANSYS solver pre-processing, special topics, and meshing, and refinement and comparison. Morning.
Is it matter of the design model or not?
So there are some. You may have a look at this once you have logged into the system. There are YouTube channels for ANSYS, and there is the ANSYS website and CFD Online is a. Now this is what you don't see much, I suppose. CFD Online is a fairly good set of resources. It's an old school website really. So it has information, nothing flashy, but a lot of information on CFD. So this was developed by the developers earlier. So CFD and the World Wide Web was supposed to be totally free when it was invented anyway. So it has the same ethos and principles behind it. So most of the,
Is that all ANSYS related or is it different?
no, any, lot of software. So there are a few other software, pieces of software as well for CFD, so it has different flavors. And some information on some academic codes as well. So there are, I mean, what you see in Fluent or ANSYS is you work through a GUI, graphical user interface. Yeah. But when I started learning CFD, we looked at the results after I have solved everything. So we used command line software. So I used to write pieces of software as well in Fortran and C, and then process it, and then once you've got the numbers, I would put it through a GUI and see the results. So
Why we don't have to do that?
well, that's how it all started, really. Yeah. So now what we do is we give the commands through the user interface.
It's really easy and really nice. Much more user friendly.
Yeah, but there was a time when now most of the problems have been solved, but you're still entering data into a black box, aren't you?
Yeah.
And get, so if you put garbage in, you will get garbage out. So it's sometimes difficult to see what's going on inside. So yeah, nowadays we used to edit. There was a software called NEdit editor software. It's like say Word, some similar to Word. So you write the program and compile it and then run it and then. But the advantage, one advantage is it takes slightly lesser time when you do it command line, because it doesn't call for the GUI or the extra resources, so you just run the code itself. So it has the minimum burden on compute resources. So yeah, just navigate through these websites. So ANSYS website keeps on changing, but ANSYS has become quite custom oriented again. It used to be a little distant from the customers, it used to be a seller website. Nowadays it's quite helpful actually. A lot of tutorials can be downloaded from there, and there is a user group as well, so you can post your problems in and then somebody will answer. And that facility is there in CFD Online as well. So what your name again? Your name?
Tom.
I know. Tom Group? No.
Tom Group.
Yeah, you're Tom Group. Somebody, yeah. What's your name?
Tristan Willis.
Yeah, okay. Sorry for
That's all right.
your name. Yeah, a quick introduction. CFD stands for Computational Fluid Dynamics. As you know, it's a combination of physics, maths and computing. So there are three branches of fluid problems: analytical, experimental and computational. So why we use computational fluid dynamics is it has become cheaper now. It used to be, nowadays, it used to be the more expensive option. because a machine would cost like 20 grand, a good one, those days.
Is that because it was less reliable as well? Like, so you just rather do the physical experiment?
Sorry?
Was it less reliable then in terms of like simulation results as well? Or?
Yeah. So it has advanced through the years, so that we have answers for all the rubbish solutions nowadays. So yeah, and what has happened is experiments. The price of experiments have gone up, cost of experiments have gone up, and the people also, the technicians, lack of technicians and so on. And yeah, I mean, I can run answers on this my laptop now, but those days we had workstations.
When you say those days, what year are you referring to?
Sorry?
When you say those days, what year are you referring to?
Last century.
Last century.
Were you born? Yeah, late 90s. Tells me how old I am. Yes? Right. Yeah.
At least not too fast.
So why CFD and why not? It's fast, more cost effective. Well, some experiments are actually prohibitive. Have you seen the supersonic wind tunnel in the N block at some point? No, right. So we say wind tunnel, but it's a very small piece of equipment. Right. So running that is very difficult. Getting pictures out of it is very difficult. But in a CFD, in your computer, you can run the flow in through a supersonic nozzle basically and get results. So that's an example of where it can help you. And certain experiments can be hazardous, and some environmental conditions you may not be able to replicate in a laboratory environment, and so on. And the other thing is, now this is true for experiments as well, but CFD, there is a knowledge base, because when we solve the problem, it goes into a knowledge base somewhere, so you can retrieve solutions to problems, standard problems, very easily. And you can test new physical phenomena as well. So if you come up with a theory, and if you can test whether the theory is right by putting it through a CFD tool. So applications can be aerospace, automotive, biomedical, chemical processing, heating, ventilation and air conditioning, hydraulics, marine, etc. And then it's used in oil and gas, power generation, sports, and you use it to simulate natural phenomena as well. So, for example, a hurricane, or to a certain part, a tsunami or something like that, or just a channel flow. So all that can be replicated. So these are some pretty pictures of different examples. So they are pretty much self-explanatory. So this is you need to distinguish between external flows and internal flows. Yes, so I guess you have an understanding. In an internal flow, okay. The main thing we have to understand is you are only simulating the fluid, only the fluid. So even if you have a pipe flow, you are given the dimensions of the pipe, but what you are simulating is the water flow, or the whatever fluid flow inside the pipe. So what you say as the wall is actually the boundary. of the fluid. So, and when it comes to external flows, so for example, when you want to simulate the flow around this car, actually for the fluid, car is external to the fluid, because what you are doing is you demarcate a domain, large domain, outside the car, and then put the car inside, and then deduct that car from that square domain, maybe a square domain. You deduct that domain, and then you have the fluid left. Okay. So you simulate only the fluid. Okay. You need to distinguish that difference. And these are some problems. This is a flow inside the vessel, so in inlet and an outlet, and this is again flow inside a building. So for example, you've done this one now for your project. So it's the ventilation inside a room. And this one is a pipe flow, not just a pipe flow with the valve in it. So what this stop valve does to the flow. So that is what we are trying to determine here. And then in marine oil and gas and power generation, you have so this is a marine problem. So there are two here actually. The flow of the flow of the ship over the water, as well as the emissions. You can look at the emissions or the flow over the ship, as well as flow underneath the ship as well. So this is water, this is air basically, or gas. And this is a oil and gas line, power. These are oil and gas lines, and this is a wind turbine simulation. So in power generation, you have another example where you can look at the effects of ice generation on power lines, etc., as well, and wind effects on power lines, etc., using CFD. In sports, so what is happening to a golf ball or a cricket ball, you can do a simulation on that. Then you can have open channel flows or natural phenomena as well. So these are examples. And then we say how it actually developed. So the evolution of the subject. So this is a historical evolution of the subject. So I would just suggest you to read this rather than me going through every line here. But basically, numerical methods is not a new subject. So it's been there for hundreds of years. Computers came in, or computer-based computers came in the 40s during the Second World War. They used a lot of numerical engines for different coding exercises. Some people say that during a war technology is developed, because without technologies you can't. It's at the end of the day, it's going to be who has better technology normally wins. So and then mechanical desk calculator. So the we have desk calculators now, electronic ones, So they used to have mechanical calculators in the 50s. So, and then the first scientific paper was published in the 60s on these ones. And then CFD codes. So first scientific paper on CFD was published in between 16 and 17. And codes are programs. Codes were generated by NASA and Boeing and so on. And then first problems are one-dimensional or two-dimensional. Nowadays we do three-dimensional problems. So it took some time for the computers to accommodate three-dimensional problems because of the lack of power. Well, I'll give you an example. So, the first computer I saw was what was called a BBC Sinclair. You might they are in they are in museum, but so that came in 1980s, late mid 80s. And then the first computer I had was 486DX, it was called, 100DX. So it had how much? 8 MB RAM perhaps? 8 MB. And 512 MB or had 1 GB hard disk, something like that. So not long ago.
When was that? When did you have that?
90s.
Yeah, in the 90s.
Megabytes back then was quite a lot of RAM, wasn't it?
Sorry?
I thought they had like kilobytes back then. 8 megabytes.
Oh yeah, I worked with floppy disks with 256 KB,
Yeah.
512,
Yeah, that was long.
and 1.44 MB. Yeah.
Yeah, I remember the computer we had as a kid. It was like that. Shit.
Back then it was like amazing. Now it's like, oh my god, I cannot believe I used this.
Okay, so the main fluids that are used in CFD are air and water. So you need to know the properties. Well, you need to have an understanding of the properties of air and water at your fingertips to do CFD. So examples could be human body, environment, auto in the sense gas burning, power generation, etc. Aerospace, sport, electronics, process industry, new materials, and integration with other fields, as you said, FSI. Yeah? So our areas of interest could be laminar versus turbulent flow, reacting versus non-reacting flow. So, okay, this is a good distinction because when you do CFD, you don't even talk about this until you come to this lecture most of the time. Consider a fluid. Yes, consider a flow inside a pipe. So what you are solving are the Navier-Stokes equations just to look at the flow field. Okay. But you don't, then you can add heat to it. So that means you solve the energy equation. But still, you don't look at reaction. Okay. With reaction, what happens is with reaction, energy is being released or absorbed, and different species will be formed. Okay. So that means, so for example, if you have combustion inside, how many constituents? You have fuel and oxygen and nitrogen, and then CO, CO2, H2O, H2, NO, noxus.
Yeah.
Yeah. So you can have multiple species, that means you have to solve an equation for each of these species. Yes? So your problem becomes much larger when you have reaction. So you cannot solve it at once, so you have to solve it step by step. When you look at the software, you will when you introduce combustion into the problem, you will realize that the time to solve it will dramatically increase. That is because the problem size increases as you introduce the reaction to it. And then you need to look at the size of the problem. It could be micro scale, large, large or very large scale. So when you talk about, you must have heard the name large eddy simulation. Large eddy simulation is for general flows, but if you are going to look at flows like atmospheric conditions, etc., atmospheric flows and so on, you have to use what is called a very large eddy simulation, because those eddies have to accommodate large volumes of space. And you will be looking at different solution algorithms which have different times to solve, and then you need to look at parallel processing as well. You already use parallel processing, so when you give the command to the computer to use 4 processors, that means parallel processing. So it uses 4 processors, or usually it's multiples of, it's a power of 2 basically. 2, 4, 8, 16, 64, 16, 32, 64 and so on. And then you have multi-phase flows, not a single phase, so it could be liquid and air, gaseous liquid and gaseous phase, or liquid and particles also. And then you have FSI, fluid solid interaction, and then you have to look at meshing also. So these are the areas of interest in CFD. So basically CFD is CFD can be disintegrated into 3 parts: pre-processing, solver and post-processing. Pre-processing is the commands that you identify the domain and solve the domain, do a mesh, and give the boundary conditions. So that is pre-processing. So then you ask the software to solve it. That is when you see those iterative lines going on. And then once it has solved or converged, once your solution is converged, then you put it through the post-processor, which is the graphical interface for the results. So your workbench in workbench in ANSYS houses all 3: pre-processing, solver and post-processing, all 3. Yes. So this gives you the CFD workflow. So you can go through this at your leisure actually, but it's fairly detailed workflow diagram. So all these happen inside your workbench. So that's what I said earlier. We used to do them separately in the early days. So we didn't have a workbench per se. Right, so you have come to the end of the very introduction. So we did a quick introduction, and then we talked about why you use the CFD, why you use CFD, history and evolution. We looked at a few examples, and we looked at the process as well. So it's fairly a quick introduction to the subject, but all of you have used CFD at some point, yes? So, yeah, I don't see any MSc students, so you all are MEng.
So you just go over what you talked about the first 20 minutes, so how many we have examples?
This is a 75% assignment, 25% exam.
Yeah.
So exam will be 20.
Is the assignment due like maybe before, like around Easter, and then the exams in May? Or is it both at the end?
Late April is the due date for the coursework. So we will have 9 classes before that. So we have 9 classes before the Easter break. 2 weeks Easter break. So it's, I can't remember the date exactly, but it's towards the end of April. So you will have good solid 10 weeks before submitting your coursework. Yeah.
And then after that, in May, is exam.
And that's only a couple of lectures after the assignment.
But those lectures, they'll just be based on the exam content.
Yeah. So how this works is the theory that we do in the first hour, that is for the exam.
Yeah.
And the 2 hours that we spend in the laboratory or the computer class, that's for the coursework.
When will the coursework brief be available to us?
Next week.
Next week?
Yeah. Yeah.
Is it?
Yeah.
Is it individual?
Yeah.
Okay.
It's hard, you know, it's hard with these things. It's coursework.
Design of fluid systems wasn't hard, was it?
Yeah.
It wasn't hard, yeah?
It was hard.
But you managed, right? Yeah?
Your course,
Which was harder, the exam or coursework?
Which one? Yeah?
it was hard.
Course.
I remember sitting and seeing everything.
Yeah, but you kept doing it, it kept breaking. Yeah, but it doesn't work. For some reason, I touch the computer, it just doesn't.
You will get over it, don't worry.
And you chose to see it.
You guys will. Okay, so the class is or is it 14 for the next couple
We
of
got you
hours?
next as well.
Sorry?
We got you next as well.
I think it's David Bishop.
Is it you didn't stay?
Yeah, it's,
Oh, you're there.
It's David there as well.
There is,
Explain how to do this.
Ross is playing about it on his own.
You've also got to take class.
So if I quickly go through this process again, so you launch your ANSYS workbench and then launch fluid flow fluent. Now it says fluid flow fluent. You can launch fluid flow CFX as well,
Yeah.
or you can. You don't have to use. You don't have to run fluid flow fluent. You can just run fluent, but to do that you need to import a mesh from somewhere else. So there are some other pieces of software that you can. Actually, you have it on Actioning, I think. Software called Rhino. Have you heard about it? Yeah. No, it's a good 3D CAD software. So that can be used to generate good meshes for complicated problems.
I thought you generate the mesh in assets. You just import the model. SolidWorks.
There is a term called CAD cleaning. Right? Okay. Now, suppose you got the drawing of this building to do a CFD problem, to solve the CFD problem. That comes in CAD software, some form of CAD software, but you can't import that model directly onto the pre-processing of your CFX or Fluent or the machine tool of ANSYS. You have to do some cleaning because the algorithms that you use to draw the structure is not the same in both the software. So a software like Rhino can be used to do this job, cleaning the drawn in another software to be suitable to be used in a CFD tool without duplicates, without holes and so on. So a software like Rhino allows you to do that. So once you've got the geometry, you create a mesh, yes, and then you set up the problem, giving boundary condition, etc. Then you give the numerical values to it, and you use a solver, and then you run the case. And once you've run the case, it can converge or diverge. If it diverges, you go back and do some changes so that you will get a converged solution, and then you post-process. So you look at the results. So basically, from the solver, after the solver, what you get is arrays of numbers, yes, in a grid. Basically. So then you have to visualize those numbers in a physical space. So that's what your post-processor does. Okay, so we will stop here, and I'll see you in the other class.